So there we go. Okay, so we're doing logs. Let me write up again. Did I write up the steps for logs? Let me do it one more time here. Oh, is the thing not on? No, it's not on. There's nothing up there. All right, that's all right. The steps for logs while you're logs. So step logs with an equal sign. Step 1, if you only have one log each side and nothing else, cancel the logs. Cancel the logs by logic. By that I mean you're not dividing or anything. You're just canceling them out because logically they can cancel. Number 2, if you have get the logs here. So this is all 2 or more logs. 2 or more. Get the logs on the same side and make one log by the properties. Adding becomes, adding leads to multiplying, subtraction leads to divide. Step 3, lose the one log. Lose the one log. Base stays the base. Other 2 switch. I think you know that step. And step 4, solve and check, meaning no negative, no 0 in a log. So there we go. There's the steps. Wrote those up before one more time. There's the steps for solving when you got a couple of logs. All right. Tomorrow's the last day to drop. If I mentioned that, I just want to be clear. This class or any of your full-term class, tomorrow is Friday. We're halfway through. This is a halfway week. We're halfway through the semester. So if you don't want a grade, drop tomorrow. You get a W in any of your classes for withdraw. It won't be on your GPA. Starting next week, you're in for a grade for sure. A, B, C, D, F on your transcript. Rest of your days on the planet, as I always say, right? Make sure that's what you want is a letter grade. All right, so there we go. 2 or more logs with a plus sign. Okay, so we look at this problem here and we say, okay, we got 2 logs. And step number 1 is rare. We did some step number 1s last time, right, where we just have one log on both sides. You know, if we just had log base 5x plus 4 equals log base 5x plus 28 or something, and nothing else at all, yeah, I would just cancel the logs, right? Because if the log of one thing equals the log of the other, then the x plus 4 must equal the x plus 28. You know, that's not what we have here. But I just wanted to be clear. That's what step 1 is saying. If you just have one log on each side and nothing else, we don't. We have something else. We have a 2. We have a third player in the game, which is normal, right? We did those first few problems in the section where we just had one log on each side. And yeah, if that's the case, just cancel the log. No big deal. That's step 1. But that's rare. Step 2 is more typical. You got to get the logs on the same side. These already are. And make them one log by the properties. So how do and remember I called it the log countdown. Didn't I? Did I say that? Maybe I didn't. Think of the other class. All right, let me tell you. It's the log countdown. I just say that's a way of summarizing all these steps just to help you because there's a lot of steps and you can put them on a 3x5 card, but it just helps to have something in your head, I think. Log countdown. So when you see a couple of logs, you should think, oh, okay, it's 2 logs right now. Next line, it's going to be 1 log, and the next line, 0 logs. It's going to go 2 logs, 1 log, no log. We're going to count down the logs. That's what those steps are doing, basically. So as you look at it, okay, how can 2 logs become 1 log? Well, that's the properties. That's the adding. Adding leads to multiplying, subtraction leads to divide, all those properties. I hope you made it through that section. What was it? 6, the previous one. We're 5.5, because that was the property section. That's how you make it in a math science class. If you don't keep up, you die. That's pretty much it. If you haven't finished 5.5 right now, it's going to be confusing today. I mean, you'll know it a little bit, but you won't be all over it because I'm using all those properties from 5.5. Really, time management, there's almost nothing more important in a math and science class. It's managing your time, I'm saying that, I'm a little bit of a hypocrite. I struggled. I'm not Mr. Perfect at all. But it's still the truth. I can still say, hey, it's true. And when I struggled with it, it gave me problems. And when I kept up, things went way better. So really encourage you, keep up in a math class with that homework. Do all you can to keep up. Because we always build. We always build on the next step. So if you haven't got the last thing and you're trying to build on it, well, then you're confused because you didn't get the last thing. I'm using those properties now and moving ahead. So try to keep up this weekend, especially catch up if you can. So, all right, so got 2 logs, want to make it into 1 log. What's that mean? Adding, and the base doesn't change. It'd be log base 5, that's not changing at all. So it's still log base 5. So adding becomes multiplying, right? And this is still 2 over here. Whoops, it's getting kind of scribbly there. We good to there? And see how I'm multiplying those? So 1 log, it's a harder job, multiplying, harder operation. Easier for 2 logs, just adding. Remember that property? Adding becomes multiplying. So if that had been a subtraction in the middle, what if that had been a minus in the middle instead of a plus? I would have put the x plus 4 over the x plus 28, huh? I would have divided them instead of multiplied them. We'll have one of those in a minute. All right, so we have 2 logs added. So 2 logs. 1 log, next line, no log. So how do I go to no log? Lose the log. Base stays the base. The other 2 switch. So cross off that log. The base stays the base. Who's the base? That 5. And the other 2 switch. What are the other 2? All that x stuff and that 2. They switch position. Instead of 5 to all that x stuff, it's 5 to the 2. And all that x stuff goes to the other side. They're getting kind of scribbly here. We good to there? So far, so good. We're out of the logs. So now we just solve. So again, 2 logs, 1 log, no logs. That's always the flow for solving logs. 2 logs, 1 log, no log. So now we're down to no logs, and so we call that a log countdown. Now we solve that thing. All right, let me bring it up here. So actually, I think I'm just going to go to a fresh page if that's okay. So 5 squared equals 5 squared equals x plus 4, x plus 28. X plus 4, x plus 28. This is question number 9. All right, so here we got. Whoops, I hit the button thing. All right, we're at number 9. So we're out of the logs. We're done with the logs. Now it just says on step 4, just solve this thing. Just solve it and check. So just solve and check. Okay, we'll solve and check. So 5 squared is 25. Distribute. X squared plus 28x plus 4x. What's 4 times 28? 80 and 32. 112? 112. Okay, 25. 25 equals x squared, and what's that? 32x plus 112. Okay, what should we do now? What do we do? Get a 0. Good. Is everybody clear on that? Yeah, you want to just know that comes up. Remember, I call it the sea monster. All of a sudden, you're out in the ocean, just rears its ugly head, just trying to say something weird to help you remember. So whenever x squared, because it will just pop up in the middle of nowhere, in the middle of doing something else. Whenever all of a sudden x squared pops up, you remember you want to get a 0. Number 2, try to factor. And what if they won't factor? Well, we'll see that in a little bit. We will have one not factor today. So subtract 25 from both sides. Get a 0. X squared plus 32x plus something. 85, 87? Does that factor? That looks weird. Let's try 87. I would, as I look at it, it looks weird to me. I would just take 87 and try dividing by things. Oh, wow. Okay, yeah, I was going to divide by 3 right away. Why we do 3? Yeah, just start. You can start with 2, but obviously 2 doesn't go in, right? Divide by 3, you get 29. You go, can 3 and 29? Yeah, they can make 32, can't they? So that one does factors. Everybody see how you come up with that? You just take the number and you just start dividing by things. I didn't divide by 2 because clearly 2 doesn't go in. It's not even. So if 3 hadn't worked, I would have went on to 4, 5, 6. You know, just keep trying things. But 3, we're 3 and 29. Sign in the middle, whatever sign is in the middle goes on the, all together with one voice. The sign in the middle goes on the, good, okay, that's good. You don't have to say as long as you do know. I'm just happy that you know. Good, yeah, sign in the middle goes on the bigger? Yeah, totally. So it goes on the 29, the middle sign is plus, goes on the 29. So, and now it's just opposite sign, huh? You know, because you said each one to 0, x minus 3 is 0, x plus 29. What's that?
Doesn't 3 need to be positive too? 3, the 3 you put a minus sign.
Oh yeah, something's wrong here. That's not going to work. You're right, Marlon. I'm not even looking close.
Well, if you add them both, it will work, right?
Yeah, what? I'm just being totally crazy. Yeah. I don't know what my problem was. They're both plus. Yeah, I don't know. Just yeah. Thank you. Yep, both plus. Good. Thank you. Move that over. Negative 3. Move that over. Negative 29. Okay. So. What's up?
Yeah.
It's all good? Got to both be plus to make plus 32 in the middle and to make plus 87 at the back. But then when we solve, when we set them equal to 0, they both become negative, don't they? So, okay, so now, remember, but you have to check. You have to check. So in other words, will those answers plugged in make any make any inside of a log, inside of the toaster, negative or 0? Let's check. Take the negative 3, go back to the beginning, put a negative 3 here. What is that? Positive 1, negative 3 plus 4 is positive 1. That's fine. Negative 3 plus 28, that's plus 25. That's fine. The inside of both those logs is positive. Great. It's all good. So the minus 3 is an acceptable answer. How about the minus 29? No, that one's a problem, huh? If you put minus 29 in there, it's going to choke them both, isn't it? Minus 29 plus 4, that's negative. I don't even need to look at the second one. I've already got a negative, so he's out. So the only answer is minus 3. Good? Questions I can answer on solving logs? So it's a log counting. Okay, so try that one. Look back at those steps. Use the recipe. I'm always giving you the recipes, right? Use the recipe. Use the steps. And mainly it's a log countdown. What's the first thing you have to do here? Got to get them on the same side, right? Got to get those logs on the same side. Give you a second to do that. So yeah, so first step, bring this log over. So we get log base 4 of x plus 7 plus log base 4 of x minus 8 equals 2, right? So get the logs on the same side and then start counting down the logs. 2 logs, 1 log, no log. Right? Count them down from there. 2 logs, 1 log, no log. Give you a second.
Professor,
Mm-hmm.
are you still able to transfer the exponents when they're being divided, right? And one's dividing the other? Because that's wait, no, oh no, my bad.
It's all good?
Yeah, when you move it over, it becomes positive. I was just looking at the negative still.
Yeah, we'll have a negative one in a minute. So 2 logs, 1 log, and it's going to be multiplied, huh? 2 logs added, 1 log multiplied, harder job for 1 log, easier for 2. That good? And then next line, no log. So how do we go to no log? We lose the log, and when we do, base stays the base, other 2 switch. So the 4 will be the base, and all that x stuff and the 2 will switch positions, huh? Instead of 4 to all that x stuff, it's 4 to the 2, and all the x stuff goes on the other side. So no log, 1 log, 2 log. Were you good to there? And keep going. So we got out of the logs. 2 logs, 1 log, no log. I would say we got out of the woods, but I wouldn't want to make a math pun. Sorry. Log, wood, sorry. Just joking around. Keep going. So now you're going to have an x squared equation. So FOIL out that right side. We're going to have an x squared equation. And that means you got to give 0, right? FOIL this side out. Boom, boom. 16 equals x squared minus 8x plus 7x minus 56. So you see x squared, you think, get a 0. Get a 0. So you got to subtract 16, right? Make 0. And where do you make 0? The opposite side from x squared. We have x squared on the right side, so make the other side 0. That's what we always do when x squared, the sea monster, rears its ugly head, right? This will be what? Minus x minus something, 72? Yeah. You can factor that, huh? You seeing that? So factor that and then check your 2 answers. And so I'll bring it over here. So when you factor that, isn't it, it's going to be 9 and 8, huh? And sign in the middle goes on the bigger. And then, you know, it's just opposite sign from there. Positive 9, minus 8, but we got to check them. Usually the negative one's bad. The 9 is good. He makes the insides positive. The negative 8's no good. Negative 8 plus 7, no way. So just the 9. We good on that one? Is that all making sense? You just get the logs on the same side, and then 2 logs, 1 log, no log. And solve from there. All is well. There it is. Okay. So there it is. So yeah, let me let you do the first step. So it's the same rules, just a little tricky there. So you got the logs are already on the same side, so start the countdown. Right, 2 logs, 1 log. So go to 1 log.
Professor? For the 1/5, when the exponent would be -1, will that flip it over?
Mm-hmm. Exactly.
Just 5.
So subtraction between 2 logs becomes division. X squared plus x over x squared minus x. Everybody good there? Right, because if that was adding in the middle, then I would have made it log 1/5 x squared plus x times x squared minus x, right? Because adding becomes times, but subtraction becomes divide, doesn't it? We good with those properties? So get rid of that. So it's subtraction, so it becomes divide. Good. So we go from 2 logs. 2 logs to 1 log All right, so 2 logs here, 1 log, and next we go to no log. So when you go to no log, you know what happens. Cross off the log, base stays the base, other two switch. Who's the base? That 1/5. He's the base. Instead of the 1/5 to all that x stuff, they switch position, and it's 1/5 to the -1, and all that x stuff goes to the other side. Good, getting the hang of that? It's always what happens when you cross out 1 log, when you lose 1 log. So 2 logs, 1 log, no logs. We got rid of the log. Okay, now what's 1/5 to the -1 power? Yeah, remember negative powers flip things, don't they? And so that'll just become 5. Remember, it doesn't make it negative, it just flips it upside down. Remember negative powers? Just flips it upside down like that. Okay. Now what? Yeah, now what do? You can do a lot of different things, but I think about the easiest thing is just put that over 1, make it look like a fraction, and then just go diagonal, diagonal. Just cross multiply. Just cross multiply like that, diagonal, diagonal. So 5 times x squared minus x is 1 times x squared plus x. You seen that kind of thing before? You know, like if you have 2 fractions times, like 9/8 or whatever, that's when you cross cancel. But if you have 2 fractions equal, that's when you cross multiply. Everybody good on those different operations in different situations? So when 2 fractions are equal, and you can make 5 look like a fraction, 5 over 1, cross multiply, get to here, diagonal, diagonal. I mean, diagonals are just distribute. And then distribute here, 1x squared plus 1x. Good to there. Now what should we do? The sea monster is on the scene. X squared is there, so what do? Get a 0. That should be your driving thought. When you see x squared show up on the scene, you think, get a 0. Get a 0. Now where? Well, get it on the side, the lower side, the x squared lower side. So notice, bring these guys over here. Because there's more x squared on the left. There's a higher x squared on the left, huh? So bring everything to the left, leaving 0 on the right. In other words, get rid of the entire right side. So minus 1x squared minus 1x. Whatever you do to one side, you have no choice but to do the same thing to the other. Gonzo, gonzo. So that leaves me with 4x squared minus 6x equals 0. Right, that good? So when you get x squared, you get 0 on the right side? Or one side? Then what do we do from there? Yeah, can you finish that up? Go ahead and factor. Factor that thing and finish it up. So that one doesn't factor with 2 parentheses, huh? Because it's not 3 terms. It's not like this one, which was 1, 2, 3 terms. The last problem had 3 terms. That's when we factor with the 2 parentheses. How do we factor this one? How do we factor here? Let's just take out GCF, huh? Just take out what's in common, because it's not 3 terms, it's just 2. So what do they both have in common? 2x leaves what? 2x minus 3. Is that good? Remember that kind of factoring? Kind of running out of room here. And then, from there, you set each part that has an x. Remember, because the 2 things are timesing to equal 0, either one could be 0 to make that times and be 0. So the first one is 0, or the second one is 0. And then just divide by 2. 0 over 2 is 0. Move this over. Divide by 2. So 3 halves or 0, maybe. But we've got to check them, huh? We've got to plug them into the original. Remember, you can't make the inside of any toaster, any log, 0 or negative. So put in the 0 for x. Yeah, there's a problem right away. It's going to make the inside of that log 0. So forget it. Throw away that answer. The inside of a log cannot be 0 and cannot be negative. How about the 3/2? Yeah, that's fine. I'm not going to work it all out. I know it's positive. 3/2, put in there and there. Well, whatever, it's some positive number. Same thing here. It's good. 3/2 is our answer. Good on that? Questions? You okay with all those steps? So subtraction becomes dividing, adding becomes multiplying when you go from 2 logs to 1 log. And, you know, negative powers flip things, huh? They're trying to be tricky. So now they got all these logs, and basically, let's make these 2 logs into 1 log. And then let's make these 2 logs into 1 log. So how do you make the 2 logs on the left into 1 log? It's subtraction, and this one's subtraction. So go ahead, make the 2 logs on the left. I'm kind of violating my own steps here, because really I say get all the logs on one side. I mean, I don't want to do that. I mean, you could. I'm just trying to give you the steps that generally work the best. There's so many logs here, I would just keep them where they're at and just combine the 2 on the left, combine the 2 on the right. It's going to be a little easier. So it'll be x minus 8 over x plus 1, like that. So that makes sense. And the other side is x minus 3 over x. They're both divide because they're both subtraction, huh? Good to there. And now what can I do? Remember back when I wrote the steps, let me go back over here, and I said on step 1, if you only have 1 log on each side and nothing else, just cancel the logs by logic. That's what we've got now. 1 log each side, nothing else. Like there's not like a plus 2 out here or something like that, right? There's nothing else. There's just 1 log on each side, no other numbers, nothing else. So it's by logs, by logic. So that's different. Y'all seeing what I'm saying here? This is where people get really confused, and it is confusing. It was confusing for me when I first learned it. I'm not base stays the base, other 2 switch. No. That's when you cancel 1 log. This is canceling 2 logs by logic. It's different, right? See how I wrote that carefully over here? And I said, this is losing 1 log when you do base stays the base, other 2 switch. This is canceling logs, plural, by logic. Different way of canceling logs. Everybody seeing that? So if you just have 1 log and you cancel, yeah, base stays the base, other 2 switch. Here I'm just saying, look, they're both log A. So if the log A of something is equaling the log A of something, well, those somethings must be equal. Or how would the log of one of them equal the log of the other one, and there's nothing else? That's just logic. Make sense? Different than just canceling 1 log. Base stays the base, other 2 switch. This all takes practice, doesn't it? There's subtle differences. There's no shortcuts from spending hours of your life working on this stuff. All right. So now what do we do to solve that thing?
I guess you can send that
Diagonal, cross multiply, right? On that. So x minus 8 times x plus 4 equals x plus 1, x minus 3, distribute. What do we got here? X squared plus 4x minus 8x minus 32. Boom and a boom. X squared minus 3x plus 1x minus 3. We get to there. So that's x squared minus 4x minus 32. Other side, x squared minus 2x minus 3. What do you do when you have the same x squared on both sides? Bye-bye x squared, right? So now we've only got minus 4x. Even though the sea monster appeared for a minute, we chopped its head off. It's gone. Right? Because there was the same amount of x squared to both sides. So we're out of the x squared. We don't have any x squared anymore since there was the same amount on both sides. So now it's just solve for x. I don't got to get a 0 and factor and all that fancy stuff. There's no more x squared. I chopped off the sea monster's head. He's gone. Right? No more x squared. Just solve for x. You can go either way you want. Whatever. I'll just add 2x to both sides. whichever way. So add 2x, gonzo. And that gives me minus 2x minus 32 is minus 3. And then add 32. And that gives me minus 2x equals something. 29. Last step. Divide by negative 2. There it is. Hopefully that's, oh no, that's not good. Negative 29. You know, the negative on the bottom, same thing as on the top, doesn't matter. That's not going to work. If you put that in there, negative 29 halves minus 8, that's going to be negative. No way. No solution. That was the only answer, and it's a bad answer. So after all that work, it's no solution. Was that fun? Seems a little pointless sometimes. No solution. Questions? We good? I better move on. I'm going to go fast. How to do that, right? All right, let me give you 30 seconds. Solve that. That should be a snap. That should be falling off a tree. Well, I don't know why it'd be falling off a tree, but as you're riding a bike, I don't have very good analogies today. Yeah, what are you supposed to do? Make the bases the same.
So that's 6 to the power of 2.
Right.
And so
Right.
7.
That's 6 squared. Good. And so then you can eliminate that and just say, well, if 6 to something is 6 to something, those powers must be equal. See, I eliminated those 6's by logic, kind of like I eliminated 2 logs. And same log both sides, same base hit both sides, just out of there. So then x is 7, right? Good? Okay, so that. All right, so now we ain't going to make the bases the same on this one. No way to make the base same. So what are you going to do? X in power. That's the issue, right? X is climbed. I mean, you can't divide by 2. You can't subtract 2. I mean, how are you going to solve for X there? You can't make the bases the same. 7 is not 2 to some power, at least not 2 to any nice power. So what do you do? Divide by 2 is not going to work. That's not 2 times X. It's 2 to the X. You see the difficulty? It's kind of weird that X is in the power zone. It's kind of difficult to deal with. What do we do? Epi, right? Epi? No? I'm confusing. What's your name? David. Okay, so what? Yeah. Exactly. Good job. Remember, that's when we do the ln, or regular log will work too. Either one. Totally right. Yeah. So let me write x in power. So number 1, try to make the bases the same. That's what we did on the last problem, right? So if x is in power, like the last one, x in power, we made the base the same, that worked great. But if you can't make the base the same, if you cannot, then ln both sides. You can do regular log also. I'll just do ln, because then ln's real convenient when we get e in a second. But regular log will work too. So yeah, I'll do ln both sides. That's right. And now why? Why do we ln both sides? Why is that so great? Because of that third property. Remember, I kind of grabbed it for you in advance with the last section. But now we officially have the property. Remember the property? What do powers do with a log? They come down, huh? That third property of logs, that's the greatest quality of the logs, that they take those powers and they bring them down. They dethrone it. Remember I did all my stories about Hitler and Stalin and getting them out of power and all that kind of stuff, right? That's logs do that. That's the great quality of logs. We have nothing else that does that. That takes something from the power zone just down to the base zone. That's a big change, right? It was in power, it's out of power. Just pulls it on down right out of power like that. Now that it's just a regular x, it's not in power, now it's cake. Now it's a super easy problem. How do we get x alone now?
You gotta divide.
Yeah, just divide. No big deal. We could do that 3 years ago, right? It's all about getting it out of power. And there's the answer. That's exactly what they want you to type in. They don't want a decimal. They want exactly that exact solution. So we've done that before, huh? So that's not really new for us. We kind of grabbed that ahead of time. Good? All right, so x is in power. Try to make the bases the same. If you can't, L in both sides. So we'll have to do an extra step here.
Wait, there's a second part to it where they ask for the decimal.
Yeah, so use calculator. Yeah, if they want the decimal, hit the buttons on your calculator. Having trouble grabbing. All right, so on this one, again, x sub r. So have you noticed the way I'm always encouraging you to think about math and science is like, recognition. I'm always focused on identify the type, pull out the correct recipe. So when you look at this on the next exam, you should think x in power. You want to have them in categories of types of problems. So x in power. You want to identify, they go, okay, X is Hitler's climbed into power. Got to get it out of power. Right? So then that's the whole log thing. But first, actually, you have to, I didn't mention last time, you have to really get the base alone. First get the base alone, then L in both sides. What do I mean get the base alone? Well, the base is 2, and we got to get rid of that 3. Because if you do the L in right now, that 3 will kind of mess you up. So get that 3 out of there first off. Get that 3 out of there. Now, L. Now you take it from there. Now L in both sides. So you have to get the base power thing all isolated. Then L in both sides on that. So L in both sides. Ln. Good, both sides. And what is the power? That's the greatest quality of logs. They dethrone powers. Good so far, good to there. And now it's just about X is just saying, I want to be alone. And X is out of power, so it's not hard to do now. Just divide. 8 and Ln2 are just numbers, aren't they? Just divide by them both. 8's gone, Ln2's gone, X is alone. There it is. There it is.
Oh, you can take out the 8 along with it?
What's that?
You can take out the 8 along with it?
Yep, because they're just times. It's just 8 times. They're just a couple things multiplied by the x, so just divide them off. Yeah, once you get that x out of power, it's just no big deal. It's just multiplication. So we just divide it. It's all about getting x out of power. Logs, that's the great quality of logs. Remember, logs are what? They're inverse exponentials, huh? So they do the inverse, the opposite of powers. They bring powers down, don't they? That's the great quality of logs. We need them for solving exponential, x in power questions. All right. Okay, let's try that one. So 2 to the 1 minus 7x is 3. So again, I hope you'd recognize on the test right away, x in power. See, x in power, you go, oh yeah, L in both sides. Right away, the bases are alone. So right away, I'll just pop an L in, L in, L in. And what happens? The whole power comes down to the front. The whole power down to the front. Okay, what do we get then? So then we'll have 1 minus 7x times ln2 and x ln3. Good so far? Now, this is going to be this can be a little bit tricky for people. You do things like this in calculus all the time, so it's good preparation. So let me help you to think right. Remember, ln3 is just a number. We could hit the buttons on the calculator and get it. I'm not going to do that, but I want you to know it's just a number, right? Even though it looks kind of bigger, fancier, ln3, whatever. ln2, same thing. It's just a number. So this is just like a number. This is like x times 5, and this is like 4 and 1 minus, it's like that. They're just numbers, huh? They're just numbers. Okay, so what? Why am I saying that? Well, what would you do with a number right here? You would distribute it, wouldn't you? It's exactly what we'll do with the ln2. It's just a number, and so is ln3. So they're just a number, so just take this thing and go boom, boom. 1 times ln2 is ln2 minus x7 ln2 equals x ln3. Everybody tracking with me? You could put these in any order. I like to put the x in the front. It's just easy to see the rest as numbers that way. There's the wall of separation. Everybody good so far? So I just took that ln2 times 1. You can put a 1 here if you want. 1 times ln2. It's just ln2. Right? And ln2 times 7x. Right? ln2 times 7 times... I just kind of reordered them. I just like to put the x in the front so it's clear. and then x times ln3. Good? But you can mix them around. It doesn't matter what order. We good to there. Now we're trying to solve for x. How do we solve for x in this situation? Remember we had this one other time. You guys never forget anything we do in here, right? Talk at you 4 hours a week. X in two locations. Got to get them on the same side. Factor the x out and divide. So let me write those steps out again. We had it back when we were doing inverse functions. We had a couple of those. So let me just say it this way. X in two spots. When x is in two spots, so notice I'm always pulling out a recipe, right? At this point, you're supposed to look and identify a certain kind of question. X in two spots, and then have a recipe for handling that. X in two spots, number one, get x's on the same side. Step two, factor out x and divide. So that's what we did back with the inverse functions when we had that happening. So you should look at this term and say, I need those two terms to be together on the same side. So I'll just grab this one and jump it over there. That way both the x's will be on the right. Doesn't matter, right side, left side, whatever. But this looks like about the easiest thing to do. So 1 times natural log 2 is just natural log 2 equals x ln 3 plus x times 7 ln 2. We good to there? Good like that. And then, so that's get the x's on the same side. Next step, factor out the x. Remember that? See it's isolated now? See how that gets the x alone? And then you can divide. Boom, boom. X is alone. There it is. We got it. Is that okay? Does that have a part 2 also, where they want you to do the decimal? Tyler, you finding it? Is anybody finding that? Does that have a part 2?
Hold on. I'm trying to work out the one.
Tyler, I need a... So they also want the decimal. So part 1, they want this. There it is. Now, you guys have your calculator? Can you do that on your calculator? Let me crank that with you on the calculator. Because this is actually often a problem for students. Wouldn't it be a bummer on the test to do all that good work and the multiple choice options are decimals? I'll probably give you one that's decimals, one that's like this. You know, and to do all that good work and then not know how to enter it in your calculator and not get any credit for the problem, that would not be what you want. So go ahead and put that in. Make sure you can do it. It is a little bit tricky, depending on your calculator. I'll say some stuff afterwards. So you should get 0.11648. How many places do they want? 11,648. So it rounds to 0.116. They want 3 places. Y'all able to get that in your calculator? If you're having any trouble, here's probably the problem. Remember when you enter things in your calculator and it's a fraction, remember what I'm always saying you need to, not always saying, maybe said once or twice. I know I say a million things. Parentheses around the bottom and around the top. Unless you have the nicer, newer kind of calculators that show it, you know, stacked up vertically as a fraction, then great. Don't even worry about it. Just enter it like it looks. It'll be all good. But if you have, like my style, the older that enter it all on one flat line, you have to put parentheses, extra set of parentheses around the whole denominator and numerator. Otherwise, the calculator won't know where the top is and where the bottom is.
I think it needs another parentheses around the bottom one. That's how mine is.
Well, yeah, they always have their little inner ones that go around the number, like that.
Because if I don't add it, then you have to do that.
Yeah, there's extra ones. I'm just meaning in addition to whatever else. Good. So if you have any trouble, grab me. Grab me after class. 10 seconds. Be able to help you with that. 116. Okay, so pi to the 1 minus x e to the 7x. X in power. X in power. L in both sides. You know the deal, right? L in both sides. Take L into both sides and bring those powers down. So pi and e are just numbers, huh? Don't do anything weird with them. They're just numbers. We don't need to do anything fancy. So feel free to check with those around you, see if you're getting the same answer. So I'll go ln. Oops, I'll just sneak an ln on both sides. And then the powers come down, the powers come down. And so we get ln pi 1 minus x, 7x ln e. Good on that first step. And what's ln e? That's just 1. Remember, they just cancel and they're just 1. So this is just 7x. The other side, ln pi is just a number. Just distribute it. So it's 1 times ln pi minus x ln pi. You good to there? Makes sense. Just ln both sides. Bring the powers down. Now you have x's in 2 locations, huh? X's in 2 locations, so get those x's on the same side. So grab this term and jump it to the other side. 1 times ln pi is just ln pi. This is 7x plus x ln pi. And then factor out the x. Like that, and then the last step, right? That's what we always do when we have x in 2 locations. Get them on the same side, factor out, and divide. Like that. Can I cancel these ln pi's? Why not? Yeah, the glue, the Costco glue thing, right? When 2 things are added or subtracted, that means they're a package deal. You cancel them both or you cancel nothing, right? You buy the whole package or you buy nothing, right? Remember, that's what pluses and minuses do. They're like Costco where they package things together and you buy both the milks or no milk. You can't just buy one milk, right? That's what pluses and minuses do in the language of algebra. If that was 7 times ln pi, I would totally cancel those ln pi's. It would be fine. That would be shopping at Save Mart. You can buy just one. But when it's pluses and minuses, they're glued together, all or nothing. So I take nothing. That's the answer right there. And calculator, they'll ask you for that too. Good on that? Questions I can answer? Be good with these x's in power? They won't get any worse than that. So, yeah, good eye, good eye. Yeah, why can't we just do this one like the way I've been showing you, 2 logs, 1 log, no log. Why can't we just do that one by hand like we've been doing? Why do they want me suddenly to use my graphing utility? Because the bases are different. Different bases cannot do by hand. Yeah, when the bases are different, the rules those 3 properties, you can't, those properties were for same bases. We can't handle different bases. So we just use our calculator. So let me help you with how you do your calculator. What do you do? Well, there's a lot of things you can do, but I think about the easiest thing, is to let the left side be y1 and the right side be y2 and then just do the intersect thing. I think that's about the easiest. Now, when you let the left side be y1, how are you going to type in log base 4? You don't have a log base 4. You can't type in log base 4 of x plus 1. There is no log base 4 thing on the calculator. So what do? Do you remember?
Log of x plus 1 over log of 4.
Yeah, good. You remember you make it 2 logs? Remember when the base is anything other than 10 or e, you make it 2 logs. So we make it log of x plus 1 divided by log of 4. That's how you do log of base 4 of x plus 1. You make it 2 logs, divided, remember? Minus, same thing with this guy, We don't have a log base 2 button either, so you make it log of x minus 2 divided by log of 2. So that's something we did in the past. Remember that? So that's y1, and then y2 is just 3, and then you just graph them on your calculator and then do the intersect. Do the intersect routine on that. Is that good on that? Remember how to do that? Do the intersect. Yeah. And just find where the intersect. Has anybody got that? Anybody got an answer on that? Let me do that real quick. Y equals, I don't know if I got time for this. I'm probably using up way too much time on all this stuff. I just want to solve them though. Let's see, x plus 1 divided by log 4. So I'm going to type them in real quick. Minus log of x minus 2. All right. Oh yeah, I should have this one already. So here's what I'm getting. When I graphed it, let me show you my little picture. So I graphed them and I got that. And so they intersect right there. Did you guys get that? Get something like that on your graph? So I'll draw it on the screen here for the video. So basically I got a little graph that kind of went like, it drew that one first, actually went below the axis, didn't it? It drew this one first and kind of went like that, and then it drew the second line and it sort of went like that. So there's the intersection I'm looking for. So I'll do the intersection routine to find that. Remember, you go to second calc, at least on the TI. Second calc, go down to intersect, and you just hit enter, and then the guess, just move it it's close enough, I think. I can't tell where it is. Where is it? There it is, close enough. So enter, guess, boom, whatever, boom. 2.22, is that number I got? Yeah, there it is, you see it. So I'm getting how many places they want? 2 places. 2.22. 2.22. Y'all getting that for your x? Let's go. 2.22 is correct. Is that okay? You guys getting that okay? It reminded me, I just want to do everything, but there's not time. The last exam I just gave y'all, exam number 2, I was talking to somebody in office hours. It's always helpful when people come in. Come and see me. I'm glad to work with you, and I learned things that can help everybody. One of the questions on the exam, not part 1, but part 2, we had to graph one, and it was a little bit tricky, huh? It was one of those, it just didn't come out nice when you first entered it, which number, well, it was different on the yellow and blue, but basically there was one, there, okay, it said the economist. So yes, let me just remind you real quick. From exam 2, part 2, on the yellow it was number 21, on the blue it was some different number. What was the, anybody have it? What was the blue economist problem? Number 12. Blue it was number 12. So 21 on the yellow, blue on the 12, and it was basically enter this function s of x equals, or no, r of x. Basically it was type into y1, or 10x 100 minus x over 50 plus x, right? And you had to make sure you remember to put parentheses around the top and around the bottom, so you'd really type it in like this: 10x parenthesis 100 minus x divided by parenthesis 50 plus x. Probably most of you remembered that. At least the person I was working with in office hours was great on that. They had that all perfect. And then they hit the graph, and they asked you to find the what was it? You read all the words, blah 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 blah, max revenue. So all we need to see is the word max, and we know, oh, we're supposed to graph. In fact, it even said it. It said, use a graphing calculator, graph the function, find the max revenue. So you're supposed to graph it and find the max. Well, when you type that into your calculator and you hit graph, unless you've adjusted your window, you'll see like hardly anything. Just like some crazy little image thing. Yeah. Oh, thanks. Yeah, I'm writing, and there's nothing for you to see. There we go. That's all the stuff I'm writing. So, so exam 2, part 2. The yellow's 21, blue 12. That's the question I'm talking to. Part 2, not part 1, part 2. Yellow 21, blue 12. It's this question about the economist. You know, this is actually R of X. R of X. It's the economist problem, blah, blah, blah. Anyway, it's just to type it into your calculator, hit the graph button, but just is probably not the right phrase. It's confusing. It confused a lot of people because if you type it in, even typing it in very correctly, and with remembering the extra parentheses and everything, and hit graph, you just get like a little squiggle of a graph, huh? What do you do about that? What do you do when you type in a function and hit graph and you just get a little squiggle like that? I mean, we're looking for something like this where we can find a max, aren't we? There's no max in that first little squiggle thing. What do you do? Got to change the window. How do you know how to change the? Yeah, right, totally. It's a window issue. It's absolutely a window issue. Because you know what it means? Does everybody get the idea? It means there's some gigantic graph out there. Yeah, here, let me make sure. I really want to sink this concept in your mind for you. It's like there really is a graph out there, and it's going way up here and coming down. There is some maximum, but our window, this might go out to 1,000 and up to 500. I don't know. You know, I just don't know. And our window is just like -10 to +10, and we're just like looking right here. You see the issue? It's like our windows we're just looking right here and say, I just see this. I don't know, it doesn't have a max. I don't know. Well, you got to adjust your window. That's the whole thing. You got to, the calculators are stupid. They don't know. They're just showing you what you asked them to show you. They don't know. So okay, though, that's hard. You can play around with window adjustments forever. And that's what I've seen students do is get lost in the world of window adjustments. I gave you one key phrase. I even sent you YouTube. Table. 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 Did you catch that? I'm sending you those YouTubes. Those are important. Remember, I said when you have trouble, hit second table. You need to know that. When you have trouble, that's back on your graphing calculator. It's right up here. Right up. See it? Well, it's kind of big. See it right there? Table. Right above graph. If you're graphing and you're getting nothing and you're like, well, how do I adjust my window? Hit second table. And there, that'll show you, yeah, that's a weird one. There we go. That'll show you the XY table, or in this case, tables, I had two functions graphing, right? That the thing is making. Why is that so great? Well, that'll show you where the values are. And if you do that for that one that we were doing on the test, it'll show you that Y values are up around 500. If I remember right. That's what I did with the student in my office hours. I said, look at that thing. We hit table for this function, and the values were up around 500. So I said, hey, we better change our Y to go up past 500. We did that. There it was. Beautiful little piece of cake. That make sense on that? If I send you those YouTubes, those are golden. I'm not just fooling around. Those are really, really helpful. You got to use those table features. All right, so 27. So they give me this. I don't even need to read these words. They give me this function. P of t equals 286, 1.011 to the t minus 2,000. And they say, hey, when is the population going to be 324 million people? So you just put that in for p, huh? 324 is 286, 1.011 to the t minus 2,000. That good to there? Making sense? Don't even need to read all those words. Blah, 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 blah. Who cares? Population's 324. Put that in for p. And now solve for t. Why? Because they said when. When means t, huh? When means t. How do you solve that for t? What am I going to do to solve this equation now for t? Yeah, good. T has climbed. He's Hitler. He's climbed into power. He's climbed into power. We got to get him out of power. So what's the first step to get him out of power?
First, we have to get the base.
Good, Samuel. Very good. First, get rid of that 286, then do the ln thing, right? Yeah, because remember, you got to get the base alone, huh? Get the 1.011 alone. First do that, and then ln both sides. Yeah, blah, blah, blah. Can I just go blah, blah, blah after that? Then it's the same. Good. We have finished. That was a